Hello, it is Sulfur 16, the chemist. Someone somewhere requested me to talk about the periodic table. What is meant by the term periodic table? This is the ordered arrangement of chemical elements into rows called periods and columns called groups. The periodic table is an icon in chemistry and it is widely used in physics and other sciences. The following are the terms you need to know, or are the terms you must know, or are the terms you must be eager to know in order to understand the periodic table. 1. Electron arrangements, metals, nonmetals, and metalloids, electrons, neutrons, and protons, trends, groups and periods, atomic numbers and mass numbers of those elements, among others. Let us talk about an atom. An atom is the smallest unit into which matter can be divided without releasing electrically charged particles. An atom contains elementary particles, and these are protons, neutrons, and electrons. What is meant by the term electrons? Electrons are negatively charged subatomic particles that can be either bonded to an atom or freely. Electrons are outside and surrounding the nucleus of an atom. Then, neutrons are uncharged subatomic particles having masses nearly equal to that of protons present in the nucleus of an atom. Lastly, protons. Protons are positively charged subatomic particles found in the nucleus of every atom. The number of protons in each atom is its atomic number. Protons and neutrons are found in the nucleus of an atom, and this determines the mass or the weight of an atom. And therefore, the mass of an atom or the atomic mass is the total sum of number of protons and number of neutrons in the nucleus of an atom. Whereas the atomic number or the nuclear charge number of element is the total number of protons present in the nucleus of an atom. Let us try to know the historical development of the periodic table. In 1815, William Plaut, an English chemist and a biochemist, made the earliest attempt to show the connections between atoms of different elements. This was 7 years after the publication of atomic theory. He found out that many atomic weights determined by Dalton and others were approximately all number multiples of the atomic weight of hydrogen. William composed that the atoms of different elements were composed of hydrogen atoms in various numbers. This all number rule, however, was abandoned soon. In 1858, Stanislao Cannizzaro, an Italian chemist, introduced the method of determining relative atomic masses of these elements. Cannizzaro showed how atomic weights of elements contained in volatile compound can be deduced from the molecular weights of these compounds. He continued to show that atomic weights of compounds whose vapor densities are known can be determined by the knowledge of their specific heats. After that great work done by Cannizzaro, there comes a British chemist called John Newlands in 1864. Newlands was the first to arrange the elements in the periodic table in their order of the increasing atomic masses. He found out that elements that were similar chemically usually occur in the 8th position, and he termed this as the law of octaves. However, Newland's work did not convince majority of the chemists because some of the elements were placed in the periodic table but assigned incorrect relative atomic masses. In addition to this, he left no gaps for undiscovered elements. In 1869, a Russian chemist Dmitry Mendeleev used Newland's basic idea to produce new kind of periodic table. He improved Newland's periodic table by leaving gaps of undiscovered elements and predicted their physical and chemical properties. Introducing a long row of transition elements. This means that elements like titanium, manganese, and iron were not placed under nonmetals, silicon, phosphorus, and sulfur as in Newland's table. There comes Lothar Meyer, a German chemist who produced a version of periodic table similar to that of Mendeleev. He left gaps of undiscovered elements but never predicted their properties. The Royal Society awarded a Davy Medal to both Mendeleev and Mayer. In 1913, a team led by an English physicist called Henry Moseley used X-rays to measure the wavelength of elements and correlated the measurements to the elements in the periodic table on the basis of atomic numbers. He then rearranged the elements in the periodic table according to their order of increasing atomic numbers. The periodic table basing on atomic numbers is called modern periodic table.